This is our CSIS 2810 final project. We created the Arduino automatic trash bot. This project was created by Armando Carrillo, David Ariza, Jeremy Watterson.
The problem we were trying to address with our Arduino-based trash bot is twofold: sanitation and accessibility. The lid of a trash can is one of the most unhygienic and germ-spreading places in the kitchen and in anywhere that trash cans are found. Another problem is that the mobility impaired often have problems opening a trash can lid to discard of their waste. That may seem a trivial problem for most people. However, if you happen to be a mobility impaired person, something as simple as discarding your waste and trash can be an obstacle. And so our Arduino-based and servo motor powered solution to this is an ultrasonic proximity monitor that registers the presence of a person, and when that person is within 25 centimeters, the trash can lid opens. And if the person stays there, the lid remains open. When the person departs from the trash can, after a pre-programmed 5 seconds, the lid will close. So this is a great solution to the problem of sanitation and accessibility with regards to trash cans.
Project, we mainly use two sources as examples and guides. The first was from Project Hub, created by Ashraf Minaj, using components very similar to ours. And the other one was from YouTube, using the I Love Creativity channel to make the design and improve our prototype.
And as I mentioned earlier, the components we used were an Arduino Uno Rev 3, an HC SR04 ultrasonic sensor, and a servo motor, as well as breadboard, jumper wires, USB wire, 9V power source. All of these components permitted us to solve the important problems of sanitation and accessibility with regular trash can lids, and that is why we built the automatic trash bot.
To simulate the project and perfect the connections, we use the Walkway platform. The ultrasonic sensor was connected to the Arduino in the way that is presented on the screen. Also, the servo motor was connected to the Arduino as shown in the screen. So this was the simulation, and after we made the simulation and it worked perfectly, we moved to the physical prototype. And then we built the prototype in a very similar way to the simulation, with only two differences. We used a breadboard to give power to both the motor and the sensor, and we also used an external power supply.
We used for the project. On the right side, there's a screenshot of the Arduino IDE and the code we used. To operate the device, we used code found in the two sources previously mentioned, in the YouTube video and in the Arduino project form. However, while testing the device and functionality, a portion of the code was altered and added to improve troubleshooting, readability, and functionality. We improved the comments and restructured some of the variables. we included a troubleshooting segment of code. So we made sure we got the right distance and position of the motor. And we included these 2 for loops so that the motor or the device can open and close in a more soft manner, just to improve user function. Functionality. When the device is powered on, the motor's position is set to the closed value, and the sensors are reset and start operating. The ultrasonic sensor sends out a pulse, and once that pulse is returned, a distance is calculated in centimeters. If the ultrasonic sensor captures a device, or if the ultrasonic sensor captures an object within its 25 centimeter range, then the motor will smoothly position its arm to the open value. The servo's arm will return smoothly back to the closed position after 5 seconds and when the object is out of range. Here is a quick demonstration of the functionality of our project. Here we have the trash can and the sensor hanging out. So right now nothing's in front of the sensor, so it starts off in the closed position. The minute we put our hand in front of it, the servo motor will open using a pen as a thing. And we can see the Arduino, breadboard, power source, everything is connected to, or even the motor and the sensor are connected to the Arduino using jumper wires. See, I have my hand in front of it, so that means that the sensor is picking it up, so it won't close. But the minute we step back, we wait a couple seconds, it'll close on its own. So put our hand in front, it'll open up, 5 seconds will pass, and then the Arduino will close it using the servo motor, and that's the demonstration. Thank you.
Finally, after building the project, we learned to use walkthrough simulation to test not only the code but also the components. We also learned that the components didn't always work as planned, and that more aspects must be taken into account to solve problems. Also, we learned to be able to do troubleshooting, and that is necessarily to search different sources and understand the processes, not just copy and paste. Thank you.